Isobars are a fundamental concept in the field of nuclear physics and chemistry. The term isobar is derived from the Greek words iso meaning same and baros meaning weight. Isobars are atoms of different chemical elements that have the same mass number, which is the total number of protons and neutrons in the nucleus. Isobars are essentially different atoms that have the same atomic mass. This is because the atomic mass is determined by the number of protons and neutrons in the nucleus, while the atomic number is determined solely by the number of protons. Therefore, different atoms with the same mass number have different numbers of protons and different chemical properties. Isobars are often used in nuclear chemistry to study the properties of different isotopes. Isotopes are atoms of the same element that have the same number of protons but different numbers of neutrons. By comparing the properties of different isotopes, scientists can learn more about the behavior of the nucleus and the forces that bind it together. One important application of isobars is in nuclear medicine, where isotopes are used as tracers to diagnose and treat diseases. Isobars can also be used in the production of nuclear energy and in the study of the structure and properties of materials at the atomic level. The discovery and study of isobars have led to important advances in the field of nuclear physics and chemistry. They have helped scientists to better understand the structure and behavior of atoms and the forces that hold them together. By continuing to study isobars and other related concepts, scientists can unlock new discoveries and advancements in the field of nuclear science. Isobars, isotopes, and normal atoms are all related to the structure of atoms but differ in specific ways. Normal atoms, also called nuclides, are atoms that have a specific number of protons, which defines the element. The atomic number of an element is equal to the number of protons in the nucleus. Normal atoms can also have varying numbers of neutrons, which determines the isotopes of the element. Isotopes are atoms of the same element that have the same atomic number, same number of protons, but different atomic masses, different number of neutrons. This means that isotopes have different numbers of neutrons in their nuclei, and therefore different masses. For example, carbon-12 and carbon-14 are both isotopes of carbon, with 6 protons each, but carbon-12 has 6 neutrons, while carbon-14 has 8 neutrons. Isobars, on the other hand, are atoms of different elements that have the same atomic mass, same number of protons plus neutrons. For example, carbon-12 and nitrogen-12 are isobars, as they both have an atomic mass of 12. But carbon-12 has 6 protons and 6 neutrons, while nitrogen-12 has 7 protons and 5 neutrons. In summary, normal atoms have a fixed number of protons and varying numbers of neutrons. Isotopes have the same number of protons but different numbers of neutrons, and isobars have different numbers of protons but the same total number of protons plus neutrons. Understanding these differences is important in the fields of nuclear physics, chemistry, and medicine, where the properties of isotopes and isobars are studied and utilized. The discovery and study of isobars can be traced back to the early 20th century, with the pioneering work of physicists such as Frederick Soddy, Kazimierz Huygens, and Otto Hahn. They were investigating the properties of radioactive elements and discovered that some elements had isotopes with the same mass number but different atomic numbers. The term isobar was first used by Soddy in 1913 to describe atoms with the same mass number. He realized that these isotopes had the same chemical properties due to their identical mass, despite having different atomic numbers. This discovery was significant because it helped to explain why certain isotopes behaved in unexpected ways in chemical reactions. Further study of isobars was carried out by scientists such as Arthur Dempster, who developed the first mass spectrometer in the 1920s, a device used to separate isotopes based on their mass-to-charge ratio. The mass spectrometer enabled scientists to study isotopes in more detail and paved the way for the discovery of new isobars. Today, The study of isobars is an important area of research in nuclear physics and chemistry. Isobars are used to investigate the properties of atomic nuclei, including their stability and decay modes. They are also used in the production of isotopes for medical and industrial applications, such as cancer treatment and radiography. Isobars have led to many important discoveries and advancements in the field of nuclear science, and their study continues to be an active area of research. The ability to identify and study isobars has expanded our understanding of the properties of atoms and the forces that bind them together, and has practical applications in medicine, energy production, and materials science. Isobars have several important characteristics and properties that are significant in nuclear physics and chemistry. These include same mass number. Isobars are atoms of different elements that have the same mass number, which is the total number of protons and neutrons in the nucleus. This means that they have identical masses and behave similarly in terms of nuclear reactions. Different atomic numbers. Despite having the same mass number, isobars have different atomic numbers, which means they have different numbers of protons in their nuclei. This results in different chemical properties. Isobaric pair. An isobaric pair refers to two or more elements that are isobars of each other, meaning that they have the same mass number. These isobaric pairs are important in the study of nuclear reactions and decay modes. Nuclear stability. Isobars can have different levels of nuclear stability depending on the number of protons and neutrons in their nuclei. In general, nuclei with equal numbers of protons and neutrons tend to be more stable than those with an imbalance of either particle. Applications. Isobars are used in a variety of practical applications, including the production of isotopes for medical and industrial use, as well as in nuclear energy production and materials science. Nuclear reactions. Isobars can participate in nuclear reactions and can be used to study nuclear structure and properties. For example, reactions involving isobars can be used to determine the half-lives and decay modes of radioactive isotopes. Overall, isobars are a fundamental concept in the study of nuclear physics and chemistry, and their unique properties make them important for understanding the behavior of atomic nuclei and the forces that govern them.